This is lesson 8.10, day 2. So before we learned about solving systems of equation by graphing, today what we're going to do is we're going to solve them by substitution. But the first couple warm-up problems are solving them by graphing. So we have our two equations here, y equals x and y equals x plus 1. So what I'm going to do is I am going to figure out the slope and the y-intercept of both, and then I'm going to graph them. So the slope of this first one, really there's like a 1 in front of the x because there's no number there. So our slope is 1 over 1, or just 1. And our y-intercept is 0. There's no plus or minus anything, so our y-intercept is just 0. Our slope for this one again is 1 over 1. And then our y-intercept is 1. So I'm going to graph these two lines. I'm going to start with y equals x. So I'm going to start at 0, 0. And then our slope was up 1 over 1, up 1 over 1, up 1 over 1. So here is my line. And then my second line has a y-intercept of 1 and a slope of 1 over 1. So we start at 1, 0, 1, and then we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and connect our points. Well, these lines are parallel, which means that there are no solutions. There are no points where these lines intersect, so no solutions. The next one, solve these by graphing. So this first one is just like our last one. Slope is 1 over 1, and our y-intercept is 1. So I'm going to graph that one quick. We'll start at 0, 1, and then we go up 1 over 1, and then we go down 1 over 1. And there is our line for the first one. Then for this next one, to figure out what the slope and y-intercept are, I need to first get this into slope-intercept form. So I am going to solve this for y. So I'm going to do 2y. Actually, I'm going to add 2x to both sides because I want that y to be by itself. So these cancel out, so I'm left with 2y equals, and then I like to start with the x, so 2x plus 2. Then I'm going to divide everything by 2, and I'm left with y equals 1x, or just x, plus 1, which is the exact same equation as the previous one. So I know they have the same slope and y-intercept. So my second line is actually going to be right on top of this previous line. They're the same line. Because that they overlap at all of these points, at every single point, there are infinite solutions. And again, there would be one solution if these graphs intersected at one point. So what we're doing today is a little bit different. We're solving these by substitution. So the steps are to replace the value of y in the first equation, solve the equation for x, write the solution as an ordered pair, and then verify that it works. So number 1, it says solve by substitution. So we have y equals 7 and y equals 2x minus 5. So what this means is that we are going to plug in the number for y into the second equation, and we're going to solve for x. So I know that y is 7, which means I can plug in 7 for y in the second equation. If it's going to let me write, there we go. So if I plug in that 7 for y, we have 7 equals 2x minus 5. Then I'm going to solve this for x. So I'm going to add 5 to both sides, and I'm left with 2x equals 12. Then to get x by itself, I'm going to divide both sides by 2. So I'm left with x equals 6. So my ordered pair, my x is 6 and my y is 7. My ordered pair is 6, 7. Then what it means to verify. Well, obviously y equals 7. Yep, that works for the first one. And then we have y equals 2x minus 5. We can just plug this in and check to see if it works. So we have 7 equals 2 times 6 minus 5. I just plugged in those numbers to that equation. Then I'm just going to make sure it works. So does 7 equal 12 minus 5? Well, 12 minus 5 is 7. So yes, 7 does equal 7. So my answer is the coordinate 6, 7. Number 2, same thing, but this time we have y equals 8. So I'm going to plug that in for y, and I'm going to solve for x. So we have 8 equals x plus 4. Then I'm going to take away 4 from both sides because I want x by itself, and I get x equals 4. Then to write my answer, I know x is 4, and I know y is 8. Then to double check, I'm going to plug those coordinates into that second equation and solve to see if it works. So does 8 equal 4 plus 4? Well, yes, 8 does equal 8. So our answer works. Okay, this third one is a little bit trickier, but that's okay. So we have these two equations, 5x plus y equals 8, and we have y equals x minus 4. So I know from this second one that y is equivalent to x minus 4. So I'm going to plug that in to y in the first equation. So I'm going to rewrite this as 5x plus, and then that's where I'm plugging this in. So x minus 4 instead of the y equals 8. And then I'm going to simplify this. So 5x plus x is really 5x plus 1x. So we have 6x minus 4 equals 8. Then I'm going to add 4 to both sides because I want to get x by itself. And I'm left with 6x equals 12. I'm going to divide both sides by 6 so that I'm left with x equals 2. So I know x equals 2, but then for y, my y, I then have to plug that x in and solve for y. So we know y equals x minus 4. So I plug in that 2 for x, 2 minus 4, and I get y equals negative 2, since 2 minus 4 is negative 2. So my solution is 2, negative 2. Then we can double check to see if this works. So I'm going to plug it into the first equation. You could really use either. So we have 5 times 2, because my x is 2, plus negative 2 equals 8. Question mark, because we're not sure. 5 times 2 is 10. 10 plus negative 2, well, 10 plus negative 2 is 10 minus 2, which is 8. 8 equals 8, so yes, this solution works. So again, we're just substituting in for the variables so that we can solve for both x and y. Okay, and then this last one is a word problem. So we have Andy ran twice as far as Ron, and Andy ran 8 miles farther than Ron. How far did each person run? So we're going to write a system of equations and solve it. So we know that Andy ran twice as far as Ron. So let's label Andy as A and R as Ron. So for this first one, Andy equals, and twice as far as Ron, that's 2 times R. Twice as far. And then we also know that Andy ran 8 miles farther than Ron. So that's Ron's length plus 8. So now we have our two equations, and we're going to solve this. So we can really, you could plug in either and it would work. So we know A equals 2R and A equals R plus 8. So let's just plug this first one into the second one. So A equals 2R. So I'm going to do 2R equals R plus 8. Then I need to solve for R. So I want to get all the R's on one side, which means I'm going to subtract R from both, which is really like 1R. So I'm left with 1R equals 8, which means R equals 8. So we know that our R, because this is like X and Y, so A and R, we know our R is 8. And then to solve for A, we know that A equals 2 times R. So A equals 2 times 8. 2 times 8 is 16, so A is 16. But this is asking how far did each person run. So this just means that Andy ran 16 miles. Wow, way to go. And Ron ran 8 miles. Okay, I also just really quickly want to show you how we could get the same answer by using substitution the opposite way. So we still have A equals 2R and A equals R plus 8. Let's say we substituted the opposite way. So substitute this second one into the first one. That just leaves us with R plus 8 equals 2R. And then we get back to that same exact spot where we take away R from both sides, and we're left with 8 equals R, which then when we plug that back in,